Hello everyone, I welcome you back to Singh Teaches AI. Hope you are enjoying the sessions that are being delivered. The content is useful for you all. Our today's topic is insertion sort. So what insertion sort is, you have gone through bubble sort already, you have gone through selection sort already. What is insertion sort and how it is different from bubble and selection sort? So in insertion sort, uh, it builds the sorted list bitwise, means it builds the sorted list one element at a time by taking one element from the unsorted portion and inserting it into the sorted portion. Now, how it is done, uh, what I am talking about right now, we will see it in the code. We will see doing it, how the number gets a place in insertion sort. So it is particularly efficient. If someone asks you where is insertion sort more efficient than others, it is particularly efficient for small or nearly sorted lists. So that might help you. We'll take an example of, so we have a list. The list say is 25314. I'll just increase the size. It is 25314, for example. So when I say it is 25314, it is unsorted. As you can see, 2 is at first where 1 should be at the first, so it is unsorted. We'll sort it. So the base of sorting is comparison. We compare these digits with each other. The first digit in this place is 2. 2 is already lesser than 5, so it is at a place where it should be before 5. But as we move 5 is greater than 3, so 3 and 5 should swap. But again, 1 is smaller than 3 and even smaller than 2, so 1 should have place of 2 in the very first place. How this all is done, so whatever number is in focus, say if we are having this number in focus, currently 5 is in focus, I will write this number as I. So this is my I. J, whatever would be, J is one number before I. So I will denote J as I minus 1 in any case. So I'll denote J as I minus 1. So 5 is I, 2 is I minus 1, or initial to 5. Hope you understood. One thing we'll use here is key. What is key value? Key would be the place which I is holding. So this is denoting my key. And any digit which is in current focus, that is denoted by L of J. So when 5 is I, 2 is there as it is, we compare this by this. J is I minus 1, which is already sorted. So we won't be sorting anything here. If key is less than L of J, the movement or the algorithm will work if my key is less than the current focus, the current number under focus. And what this key is, this key is just a variable where that number's place would be stored. So in this case, when the first one is not changing anything, if we shift to second one, now 5 becomes j minus 1, 5 becomes j is I minus 1, and 3 becomes I. So it becomes 2. In this case, this becomes your I, and this becomes your j, which is 1 minus I. I'll denote it by I. And the number before it is j, which is I minus 1. So here our key would be 3, because we are currently focusing on 3. Now, what will happen? This 3, it will not just jump here. First of all, we'll get a space here. A space would be created between 2 and 5. Let's denote it by dash. So it's just like you are playing with cards, and currently that number 3 is in your hands. The rest is sorted as it is. Now you have to place the 3 number card between 2 and 5. It's as simple as that. So after you place it here, your new list becomes 2, 3, 5, 1, 4. Now your I shifts to 1, your j is 5. Algorithm plays again, and now when I knows that okay, it is even lesser than 5, lesser than 3, lesser than 2, then it creates a space before 2. Let's denote it by dash. 2, 3, 5. 1 is in your hand, 4. And that's pretty much how the algorithm works, the insertion sort works. Let's jump to our coding space. So this was what we did in bubble sort and selection sort. If we code, if we code for insertion sort now, our list is 2, 5, 3, 1, 4. N is the length of L. For I in range, what's the range? It's till N. So 1 till N, where N is the last number. What our key is. So it's talking about position and minimum. We'll talk about key and J. So our key is and J is 1 less than I. While J is more than 0 and key is less than the current value, means your key value should be less than current value. It was good. Yeah. Your new one would take away the keys value. So This is before while runs. Your j is obviously greater than 0. Your key value is less than uh, the current value you have in your hand, the current card in your hand. Then your lj plus 1. L of j is j is I minus 1. So L of j plus 1 is the current card you are focusing on, L of j. And your j is again j minus 1, which is already depicted here. So let's see after running this code. L is this, N is the length of L. So guys, do you see what the issue is? All right, our L is not sorted enough. This should be the one that we should use here. So when we have replaced it with commas, you have your selection sort 1, 2, 3, 4, 5. This is exactly as it should be. So with this, we have completed sorting algorithms. There is one more quick sort. Quick sort, I'll probably share it in a quick story rather than a full-fledged video. So stay tuned to learn more. More videos are coming for you to keep learning. Till then, keep learning. Bye bye. We'll meet again.